Okay, this is crazy. So Google just came up with a new AI called AI Co-Scientist, and this has already come up with new legit drugs that can treat cancer. This has already been verified in real life. Plus, it came up with another drug that treats liver disease, and this is also verified. Plus, it made a new discovery by itself about antibiotic resistance, just to name a few of its breakthroughs. So this is an insanely powerful tool, and that's exactly what we're going to go over in this video. We're going to talk about this AI Co-Scientist, how it works, what it does, and what are some impressive achievements. Now, don't worry if you don't have any science or technical background. I'll explain this in simple terms so that you can easily understand it. So jumping right in, Google just released their new system called AI Co-Scientist. Here it says it's a multi-agent AI system built with Gemini 2.0. This is their most performant AI model to date, and this acts as a virtual scientific collaborator to help scientists generate novel hypotheses and research proposals, and to accelerate the clock speed of scientific and biomedical discoveries. So, as the name implies, Co-Scientist is an AI that can do science, but this is designed to augment and collaborate with human scientists, not replace them. So think of it as like a super smart assistant that can help you come up with new ideas and solutions to really complex scientific problems. Now, we're going to go over how exactly this works, but first let's look at some insane breakthroughs that it has achieved already. Think of this AI Co-Scientist as a chatbot assistant. So first, it takes in a prompt from the scientist, and this is just using natural language. So if the human scientist prompts it with suggest an existing drug that could treat leukemia, well, that's what the AI Co-Scientist does. It goes through this rigorous process of a team of agents working together, which we'll go over in a second, and then it keeps iterating for a while until finally it outputs these candidates. Now, this is just digital, right? This is virtual. Nobody has tested whether this is legit yet. Now, the crazy thing is, next, the humans actually tested these candidates in real life. So this is the blue and the green lines. And then the y-axis is basically the leukemia cell activity. And they showed that indeed, if you increase the concentrations of these drugs, it will lower the leukemia cell activity. In other words, these new drugs proposed by AI Co-Scientist actually work in treating or at least inhibiting leukemia activity in real life. How insane is that? We are no longer dreaming of the idea that AI could one day cure cancer. Today, from this announcement, we already have an AI that has suggested some new drugs that could legitimately inhibit cancer activities in real life. So here it says the AI Co-Scientist proposed some new candidates for treating leukemia, and then subsequent experiments validated these proposals, confirming that the suggested drugs do inhibit tumor viability at clinically relevant concentrations. So that's just one example. Here's another example. What if the human got it to identify novel epigenetic targets for liver fibrosis? Basically, this means identify potential new targets for treating the scarring of the liver, which is called liver fibrosis. Now, this is a super important issue because liver fibrosis is a severe disease that can progress to liver failure and hepatocellular carcinoma, in other words, liver cancer. So we can prompt this AI to identify some new targets for liver fibrosis, and then it goes ahead and does its magic, which we'll talk about in a second, and afterwards it indeed identifies some new targets. And here's the result. So the y-axis shows the amount of basically liver damage. So the higher this amount, the more the disease has progressed. And then if you look at the first bar, this is after you add a fibrosis inducer. This is adding something to the liver to cause it to have fibrosis. And then this second bar is a fibrosis inhibitor. This is a known drug that we then add to the liver to reduce the amount of fibrosis, which, as expected, this bar should be lower than this bar. And then these four bars on the right are some candidates suggested by this new AI Co-Scientist. And you can see that all four bars are below this initial bar. So indeed, Here it says 4 drugs on the targets suggested by the co-scientist decrease the fold change of the fibroblast activity. In other words, all 4 drugs suggested by the AI co-scientist work in reducing the amount of liver fibrosis. And by the way, they tested this on human livers. So it says here, the experiments were conducted in the human hepatic, or basically liver, organoid system. So this isn't a mouse or another animal. The scientists have proven that these targets suggested by the AI co-scientist actually works on human livers in reducing fibrosis. Again, this is a huge breakthrough. We now have an AI where you can just prompt it to come up with some ideas or candidates for drugs, and as long as you pump enough compute into the system, it will actually give you some legit candidates. Like, these are proven to work in real life on humans. Alright, next up, this finding might be even cooler. So, this AI co-scientist also proposed a pretty groundbreaking discovery that helps us understand antibiotic resistance. Now, if you're not familiar with this term, let's take a step back and look at what is antibiotic resistance and why is it so important. Now, of course, antibiotics are used to treat bacterial infections, which is a huge global health concern. Like, it kills millions of lives each year. And the thing is, bacteria, they can evolve over time. So if we keep treating them with antibiotics, eventually, after many generations, these bacteria might evolve to resist these antibiotics. In other words, the ways we use to treat these bacteria infections may no longer work. So this is a huge problem. We need to understand how bacteria become resistant to these antibiotics, and how do we develop more effective treatments. And this brings us to this term called CFPICIs. These are basically special genetic elements that can move between bacteria species. And as we know it, these carry genes that help bacteria resist antibiotics and cause disease. So these elements are unique because they can be found in many types of bacteria, and they can be passed from one bacteria to another. So if we can understand how these work, how do they move between bacteria, and how do they help spread antibiotic resistance, then this can help us immensely in fighting infectious diseases. Now, here's the thing. Since 2013, scientists have already been looking at this question. And then in 2015, scientists asked, why are these CFPIs found in so many bacterial species? And then after 10 years or so of research, we humans finally have some strong evidence indicating what's the role and importance of these CFPICIs. These findings are very recent and they have not been published yet. Now, here's the crazy thing. The researchers asked the same question posed in 2015 to this new AI, and in the span of just 2 days, this AI was also able to come up with the same conclusion as these recent findings. Note that the AI did not have access to this data. This is not published data. But after spending 2 days scraping and understanding all the scientific knowledge about this topic, it was able to come up with the same conclusion. So here it says, the AI co-scientist independently and accurately proposed a groundbreaking hypothesis as its top-ranked suggestion. This finding was experimentally validated in the independent research study, which was unknown to the co-scientist during hypothesis generation. So how insane is that? This AI scientist independently came up with the same hypothesis, the same conclusion that humans have come up with, but they spent like a decade, whereas the AI scientist just spent 2 days. So those are some of its groundbreaking achievements so far. I hope you can see how impactful this is. Next, let's look at how this actually works and why this is so useful. To start off, let's look at what are some major problems that scientists are facing. Why do we even need this AI scientist in the first place? Well, scientists face a huge challenge when trying to come up with new ideas. There's just so much information out there, it's really hard to know where to even start. They have to read through a ton of papers and try to understand complex concepts, and then come up with a new idea that builds on what's already known, but that doesn't exist yet. Now imagine you're a scientist and you want to study leukemia. You want to find a cure for leukemia. Well, if you just search leukemia in Google Scholar, there are over 2.6 million results in the scientific literature. So how on earth, as a human, are you able to, read through all of these papers, synthesize all the breakthroughs, all the key ideas from each one, and then come up with a new idea that builds on what's already known but hasn't been done yet? This is an extremely cumbersome process. Thanks to Tonka for sponsoring this video. Tonka is an AI-powered messenger with long-term memory that seamlessly integrates into your messaging experience. It aims to reimagine business organization with AI. Think of it as like turning business conversation and context into your team's second brain. It has its own messaging platform, and it also integrates with your existing tools like Gmail, Outlook, Slack, and WhatsApp. Here are some use cases of Tonka. It can help you smart reply from integrated platforms like Gmail in just a few clicks, saving you a ton of time. From just one click of a button, you can get it to automatically craft a reply for you, or also customize the reply by prompting it with more guidelines. Tonka also brings its memory into every group chat, helping you set goals, keep track of group discussions, and more. It's like an AI employee with different roles in different groups. You can pull it up at any time to set goals or do certain tasks. It also has essential features for team communication, such as video meetings, calendar, memo, wiki, translation, and more. Its proprietary framework, called OMNE, tops the benchmark for general AI assistants due to its advanced memory. Get early access to Tonka from the link in the description below. It's absolutely free to join. Supercharge your decision-making with AI. Now, fortunately, we do have existing AI tools like OpenAI's recent Deep Research, which helps you synthesize all the information you need. Instead of manually searching through the scientific literature and then reading all these articles on leukemia, you can just use Deep Research and ask this AI to synthesize all the information we know about leukemia. And then this Deep Research is basically an AI agent that would autonomously scrape the web and find all the relevant data you need and then compile it into a nicely formatted technical report. However, with Deep Research, you're just synthesizing existing information. It might not be able to identify knowledge gaps or come up with completely new original ideas. And that's where Google's co-scientist comes in. So not only can it do standard literature review, summarization, and deep research, in other words, synthesizing all the information we have out there on a given subject, but this AI co-scientist is intended to also uncover new original knowledge and to formulate demonstrably novel research hypotheses and proposals, building upon prior evidence and tailored to specific research objectives. So this is also designed to suggest new ideas and paths we can take in order to solve a specific problem. Plus, many modern scientific discoveries come from combining knowledge from different domains or different fields in science. So this is transdisciplinary. The problem is, it's really hard for scientists to connect insights from domains or disciplines that they're not familiar with. So for example, if you're a microbiologist, then you're probably going to be really familiar with everything in microbiology, but you're probably not going to know so much about quantum physics or ecology. So because scientists are kind of entrenched in their own little knowledge bubble, it's really hard for them to cross disciplines and think of some new approaches to solve a particular problem, even though this has led to a lot of really cool modern breakthroughs in science. So those are some of the main problems that scientists face. And the researchers at Google specifically designed AI co-scientist to address these issues. So next, let's look at how exactly this works. First, it takes in a prompt from the scientist, and this is just using natural language. So for example, you can go to it and say, find me a cure for liver disease. And it would go ahead and scrape the literature, synthesize all the information, and then generate new hypotheses, a detailed research overview, and experimental protocols. Now, this AI co-scientist is made up of a team of specialized agents. So the scientist's prompt is fed into this AI, and then first it goes through this generation agent. As the name implies, this agent is responsible for exploring the scientific literature and then coming up with new ideas, generating new hypotheses. And then next we have a reflection agent. So this thinks critically about each idea that this generation agent generates. And it does a full literature review, seeing if this new idea is worthwhile. It does all these reviews, it does some deep verification to basically evaluate the ideas from this generation agent. And then after reflecting, after evaluating all these ideas, it actually goes through this ranking agent to rank these ideas based on the quality, based on how probable it is, and this ranking agent can give feedback to the generation agent. For example, it can say, all right, these ideas are not good, come up with new ideas, or these ideas are good, but there's still some room to improve. Please revise them further. All right, so this is a constant feedback loop. And then in addition to this feedback loop, we also have this evolution agent, which is in charge of improving ideas over time. So it continuously refines the top-ranked hypotheses from here, and it also simplifies concepts for clarity, plus it might even pull in some additional data from the literature to extend its idea. And next we have this proximity check agent. This basically creates a proximity graph for all the generated ideas, and it clusters similar ideas together to avoid duplication. And this basically provides an efficient exploration map of, all of the ideas that have been suggested so far. So basically, it makes sure all the new ideas are distinct and unique and are not redundant. So this cluster map is then passed on to this meta review agent. This agent is basically responsible for looking for patterns in the data. So it synthesizes all the data that this co-scientist has gathered, and then it tries to identify recurring patterns. And then it uses these findings to enhance the quality of the generated ideas. Also note that there's a feedback loop here with this ranking agent. Note that this entire system improves iteratively. We have these self-improving loops, and through every round, it keeps improving and generating new ideas or better ideas until we get high-quality, optimal outputs. And also notice the co-scientist uses additional tools to supplement its data collection. So this includes web search and specialized AI models to improve the grounding and quality of generated research hypotheses. So grounding just means comparing the AI's output with the ground truth to make sure it's not hallucinating, to make sure it's not making stuff up. And by the way, the human scientist can also give feedback along every step of the process, right? It's basically interacting with this AI co-scientist via a chat interface. So it says here, the human can converse with the co-scientist in natural language to specify research goals, incorporate constraints, provide feedback, and suggest new directions for explorations via the user interface. So a super powerful, but yet intuitive and easy to use tool. With this design and with these feedback loops, the AI basically learns and improves over time. These agents can basically debate with themselves and argue about which ideas are the best. It can also get feedback from the human scientist, telling the AI what they think of the ideas. Plus, it also uses tools to search the web for more information if needed, plus some grounding tools to make sure this information is actually accurate. The cool thing is, this system can scale. So if you give more computing power, it actually gets better at reasoning and coming up with new ideas. That's because this system uses test time compute. And this is what we've seen with the latest thinking models like OpenAI's O1 or O3, or the DeepSeek R1. So how this works is, at least for previous non-thinking models like GPT-4 and Claude, they just spit out the answer immediately after you prompt it with something. They don't actually take time to think, right? So these are the regular or traditional LLMs. But this new family of reasoning LLMs like O1, O3, and DeepSeek, they don't answer you immediately. After you prompt it with something, they actually take some time and of course some compute to actually think through its answer before giving you a final response. And the performance of this is way better than these traditional non-thinking models. Now, in theory, the more compute you give these reasoning models, or basically the longer it takes to think, then the better quality answer you could get. And this component is scalable. So if you do have more compute, then you could get it to think longer and therefore give you better answers. And that's exactly what it's talking about here. This also has flexible compute scaling. So here the line in triangles is the performance of this new AI co-scientist. So notice the more time you give it to think, the better its answer is. So the y-axis is basically a measure of performance. Note how it's way better than their latest and best model, Gemini 2.0 Pro and Gemini 2.0 Flash Thinking. Plus, it's also way better than a human expert, which is all the way down here. So, one could say we are already at the point where AI is better than a human expert, at least in terms of scientific discoveries. Here's another chart showing the novelty, or basically how unique, how new or creative the idea is, and also the impact of the idea. How game-changing is it? And then note that, again, if you compare AI co-scientist with Google's leading AI models, as well as OpenAI's o1, then Google's AI co-scientist is the best performer. Now, interestingly, they did not include OpenAI's o3, which is their best model. That being said, OpenAI has not released o3, so that's why it's not included in here. Google couldn't actually calculate a score using OpenAI's o3. Anyways, that sums up my review of this new AI co-scientist by Google Research. This is quite a technical, scientific video, but I hope it was easy for you to understand, and I hope you can see how groundbreaking this is. Like I said, we're already at the stage where we have an AI that can help us generate new ideas for cancer treatments or treating liver disease or who knows what else we can prompt it to do. And these ideas have already been validated and verified to work in real life. These are super exciting times, so buckle up and try not to die, because I think in the next 5 years, we're going to see some huge breakthroughs, and we might even be able to fully cure cancer, diabetes, dementia, and even figure out longevity. Anyways, let me know in the comments what you think of all of this. As always, I will be on the lookout for the top AI news and tools to share with you. So if you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Also, there's just so much happening in the world of AI every week. I can't possibly cover everything on my YouTube channel. So to really stay up to date with all that's going on in AI, be sure to subscribe to my free weekly newsletter. The link to that will be in the description below. Thanks for watching, and I'll see you in the next one.